So we're going to look at time value of money, and the key concepts we're going to look at under time value of money will be the interest, the annuities, and amortization. So the key terms we're going to use under this subheading will be the principal. Whenever we're dealing with principal, we're dealing with the present value, the amount of money we're starting with, the present value. We're also going to use R, which is our real interest rate. This is the interest charged or earned on monies invested or monies borrowed. Nominal interest rate is denoted by the letter I. The time is usually in years, unless otherwise compounded using the term M. If it's annually, you're earning interest once a year. Semi-annually, twice a year. Quarterly is 4 times, monthly 12 times, and weekly 52 times a year. If you're earning daily, we are talking about 365 days. So compound interest is simply the difference between the future value and the present value, where simple interest is simply a percentage multiplied, principal multiplied by the rate multiplied by the time. Okay, and the compound interest is simply the difference between our future value minus our present value. Future value is simply the money we expect to earn in future. Present value is the money that we have now. So in an event that we are given questions to understand or to compute the simple interest, we'll be given an amount that we have. For instance, we have an amount now which is 5,000 kwacha, and this 5,000 kwacha is meant to stay for 4 years. At a rate of 10%. So we want to calculate how much interest we're going to earn. So simple interest is simply PTR. So our principal will be 5,000. Our time or our rate will be 10%, 0.10, or we can show the percentage as it is, and the time in years is 4 years. So simple interest in this case, cancel these 2 zeros, we're going to have a final answer as 200 kwacha. That will be our simple interest. Our compound interest will require us first to find the future value. Our future value is given by present value 1 plus r to the power t, where our present value in this case is 5,000, and our interest rate is 10%. The power time, which is 4 years. So this will give us 5,000, open brackets, 1.10 to the power 4. So what are we getting in this case? What are we getting?
7,320.5.
Okay, so this is an amount that you expect when you invest 5,000, you get 7,320.5. The compound interest is, however, the difference between the two. So the future value, which is 7320.5 minus the present value, which is 5,000, what do we get? 2320.5. So this is how we find compound interest. To compound is to add interest. So the very question here where we're given, for instance, we're given 1,000 kwacha and our interest rate is 10%. And the time is 3 years. So number one, find the future value if compounded annually. Find the future value if compounded semi-annually. Find the future value if compounded quarterly. So can somebody lead us in any of these three from what I have discussed? So if it's annually, general formula will be what? Future value is equal to present value 1 plus r to the power t. So this one will give us 1,000 and 1.10 to the power t, which is 3 years. That is the future value we're going to have. Okay. If it's semi-annually, the formula will be slightly different. Each time we're compounding more than once, the rate is divided by the number of compoundings, and the time is multiplied by the number of compoundings. So this means we're going to have 1,000 here. We're going to have 1 plus the interest rate, which is 10%, which is 0.10, over semi means 2. So 2, bring the 2 times the time here, which is what? 3 years. So here we're going to have 1,000. You're going to have 1.0205 to the power 6. So you get the figure there. Quarterly, we're going to, where there's m, we're going to put what? F4. So 0.10. Our m here is 4. Then here we're going to have 4 times what? The 3 years. So this will give us 1,000. Then here is 1.025 to the power 12. The more you compound, the higher the figure. So the value you're going to find here as x, as y, as z will be increasing because we are compounding. So these are called future values. In the event that you now want to calculate a series of equal payments, this is 0, 1, 2, 3. Here we have 1,000 kwacha Here we have 1,000 kwacha, and here we have 1,000 kwacha. So a series of equal payments is called an annuity. An annuity. So this one will stay using the future value formula. Suppose we are given our interest rate, the same 10%. Then we are given our time as 3 years. And also we are given our present value as 1,000. So the question will be, suppose equal investments, equal payments are deposited in an account of 1,000. So whenever you see the word equal, it's called an annuity. An annuity is a series of equal periodic payments. An annuity is a series of equal periodic payments. So this 1,000, for it to reach year 3, it will stay how many times? 2 years. So we're going to put 1,000, 1.10 to the power what? 2, because this is 1, 2. So it will stay in the account 2 years. So when you multiply, we're going to get 121, 0. This amount to reach year 3, it will stay how many years? 1 year. So 1,000, 1.10 to the power 1. It will give you 1,100. This one here, it remains as it is. But if I want to show you the working, the same thing, 1,000, 1.10 to the power 0. To remain what? 1,000. So when you total up this, we're going to get that 310. This is what is called a future value of an annuity, FVA. Future value of an annuity for 3 years. It's a series of equal periodic payments. So an annuity is a series of what? Equal payments. I'm trying to be as basic as I can be so that most of you who are not reading, it may be very easy for you to understand as we look at the exam type questions. An annuity has what? Equal periodic payments. So these are usually regular payments. And if they're paid at the beginning of the period, they're called, at the end of the period, they're called ordinary annuities. If they're paid at the beginning of the period, we call these as annuity due. We have different types of examples of annuities. We have rentals. We have mortgage payments, insurance payments, okay, salaries. These are examples of annuities. What other examples do you know of regular payments? Retirement payments, okay. Okay, insurance, school fees. These ones are ideally supposed to be made in regular payments. So whenever it's paid at the beginning of the period, it's called an ordinary, an annuity due. At the end of the period, it's called an ordinary annuity. Now, everything we're going to look at here will both be either a present or a future value. present or future value. So if we're dealing with one single payment that we are expecting in future, it's called a future value. But if we're dealing with a series of future payments that are due in future, we call them what? Future value of an annuity. So a present value is simply 1 over 1 plus r to the power n. This is just a present value. A future value, what we're doing is simply 1 plus r to the power n. This is a present value factor. Then you can multiply by the payment. If we're dealing with an annuity, we have 1 minus 1 plus r to the power negative n over r. And if you're dealing with the future value of an annuity, 1 plus r to the power n minus 1 over r. Now these are very key formulas under annuities. Very key formulas under annuities. Okay, so a question will come to say, suppose a 1,000 kwacha is deposited now at what? At 10% interest. To what value will it grow in 3 years? What are we talking about? A future value. To what value will it be in 3 years? So it's one single deposit that will need to grow in 3 years. So what formula are we going to use? The future value formula. Future value is equal to present value 1 plus r to the power t. So here our present value is 1,000. 1 plus r, which is 0.10. To the power t, 3 years. So 1,000, 1.10. What are you getting to the power 3? Quickly. What are you getting?
The final answer, it's 1,331.
So this is compounded annually. 1,300
and 31, 1,331.
Okay. Are you sure? You first start 1.1 to the power 3, then you multiply times 1,000. Confirm the rest. Is that correct?
Yes, that's what I found also.
Okay, that's what you found as well. Okay.
Yes.
So 1.1 to the power 3 is what?
It's 1.331.
All right. So this is the amount we're going to get after 3 years. But suppose you are given, we are told part B, equal 1,000 are deposited in an account. Equal amounts of 1,000 are deposited for 3 years. Equal 1,000 deposited at 10% for 3 years. Part A, find the future value of an annuity. Future value of an ordinary annuity. Part B, find the future value of an annuity due. What is the difference between these two? The future value of an annuity and the future value of an annuity due. What is the difference between these two?
The future value of an annuity is for an annuity payable at the end of each year. And for B, its future value of annuity is paid at the beginning of each year.
Great. So the future value of an annuity at the end of each year is called an ordinary annuity. So this one is given by the formula 1 minus the future value. So it will be future value starts from here, 1 plus r to the power n minus 1, everything over r. So here we're going to start with 1,000 kwacha. That is a payment. Then 1.10, that's the interest rate, to the power what? 3 minus 1 over the interest rate only, 0.10. Okay. So when you compute that, you're going to have 1,000 here, and what is in the brackets will give you 3.3. Calculate. What is it giving you? 3.331. What is it giving you? Yeah, 3.331. You give 3.330 to give a 3 point here. Such that when you multiply this, you're going to get 3,310. Okay. That is how we calculate that.
Hello, Innocent. Sorry, Collins. I got lost.
Okay.
On the 3,310, is that the final answer?
Yes, the 3,310 is the final answer when you multiply it to the 1,000.
So it's 1,000 times, so it's the 1.1 to the power 3 minus 1 over the rate, or which is 0.1. Okay, right, that's fine.
Okay. So in the event that you want to use a table, you can simply write a future value of an annuity is equal to the payment, then here we put future value factor annuity. Here we check under what percent was that? 10%. And under the period of 3 years, 3. So you go to the table. This is a table we'll be given. It's called a financial table. So you need to check under the future value annuity. So you need to be very careful what you're looking for. This is present value, future value interest factor, and the present value interest factors. But we're not looking at the interest factors, we're looking at the annuities factor. So this is a future value interest factor for an annuity. So 10% is here. Then you check under 3. 10% under 3. What are you finding? 3.310. 3.310. So here you put 1,000. Here you put 3.310. That's the annuity factor. When you multiply that one, you're going to get 3,310, the same answer you got. So this is using the tables. Using the number line, I already showed you that you put a projection. Here, 1,000, 1,000, 1,000, they're all going to the future. This is twice, so you put 1,000, 1.10 to the power 2, you get 1210. 1.1 to the power 1 times 1,000, you get 1,100. And this 1,000, and add them, you still get the 310. So you see you're able to find the same answer using 3 different methods. Okay, now suppose this 1,000 is earned after a period of 3 years. At an interest of 10%, compounded annually. How much must we So in the event that you are being asked to compute the present value, how much must you deposit now to earn an amount of 1,000 after 3 years if the interest rate is 10%? So we know this formula here. What have we been given? A future value, 1,000. What are we looking for? Present value, we don't know. But our interest rate is 10% after 3 years. So to find the present value, we'll make PV subject. So 1,000 over 1.13, 1 to the power 3. So what do you get as a final answer? What are you getting as a final answer?
$751.31.
751.31. So the present value must be what? Must be smaller than the future value. All right. Then an examiner will also ask you, how long will 1,000 kwacha take to grow to a future value of 4,000 kwacha at an interest rate of 8%? How long will 1,000 kwacha take to grow at an interest rate of 8%? What are they asking for? Time. How long is time? So future value should be equal to present value 1 plus r to the power time. So our future value is 4,000. Our present value is 1,000. Our interest rate is 10%. Our time is what we don't know. So we divide both sides by 1,000. So divide here by 1,000, divide this by 1,000. What do we get? 4 is equal to 1.10 the power time. So to find each time you are looking for something in the power, we introduce logs. So here we have log 4, and here we have log 1.10 the power time. So this t will fall down.
Excuse me, Collins. If our rate is 0.08.
Oh, our rate is 0.08. So let me just, for the sake of uniformity, let me put 10%. In my mind, it was 10%. Thank you for that. 10%. Thank you for that. So here we're going to have t times log what? 1.10. So we're going to divide both sides by what? 1.10. What becomes our t? Divide by log 1.1. So our t will be log 4 over log 1.1. What are we getting? Log 4 over log 1.1. What are we getting? I hope you know where to find the log on the calculator.
For log 4, it's 10,000.
Just compute it once together. Log 4 over log 1.1. What's the final answer?
14.545.
14.545. So this is the time it will take for it to grow to 4,000. Also, you'll be told at what rate will 1,000 kwacha triple. At what rate will 1,000 kwacha triple in 5 years? At what rate will 1,000 kwacha triple in 5 years? So we know present value is equal to future value is equal to present value 1 plus r to the power t. So what is our future value? 3,000. What is our present value? 1,000. Where did we get the 3,000? The weight triple. So 1,000 times 3 means it has tripled. Then here we have 1 plus r. R we don't know, but the time is 5 years. So we divide both sides by 1,000. When we divide both sides by 1,000, we're going to have a 3 this side. So we have 3 is equal to 1 plus r to the power 5. The power 5. This is the power 1. If whenever there's nothing, it's the power 1. So we cannot find this until we remove the power here. So how do you remove the power? By multiplying by the inverse. If there was a 7, would have done 1 over 7. There's a 5, would have done times 1 over 5 on both sides. So 1 over 5 is same as 0.2. So here we're going to have 0.2 is equal to 1 plus r, because this cancels. So what is 3.3 to the power 0.2? What is 3 to the power 0.2? Pardon?
1.245.
1.245. When you subtract 1, what are you getting? 0.245, which is 24.5%. So this is how we find the interest rate. Interest rate. Back to the annuities, we did the future value of an annuity, which was given by present value 1 plus r to the power n minus 1, everything over r. This is how we find the future value of an annuity. Find the present value of an annuity. It's a payment. And here we have, even here you can put payment, the periodic payment. But here we're going to have 1 minus 1 plus r to the power negative n, everything over r. So using the same question, if our payment is 1,000, periodic payment, equal periodic payment is 1,000. The interest rate is 10%. and the time is 3 years. You'll be asked to find the present value annuity and the future value annuity. So the present value annuity, put 1,000 kwacha here, and here we put 1 minus 1.10 to the power negative of 3, everything over 0.10, which is the interest rate. So this will be 1,000 times what you calculate here is 2.487. Or you can go use the table. You check under, this is the future value of an annuity. You go to present value of an annuity. The present value, you check under 10%, under 3, 2.487. 2.487. So this is a 2.487 that you have there. You multiply by 1,000, you get 2487 as the present value of an annuity. Present value of an annuity. Very important. It is because of the present value annuity that we understand what is called loan amortization. To amortize a loan is simply to make a payment plan. How am I going to pay back this loan? So formula for loan amortization is the amount of loan, the payment, then here we use the present value interest factor of an annuity. Rate against time. So if you have a loan of 1,000 again for 3 years at 10%, how am I going to repay this loan? The first thing is you need to find the periodic payment. So the amount of loan is 1,000. So amount of loan, periodic payment, some books will use the letter R, present value annuity factor. So here you put 1,000. The rate, the periodic payment, we don't know. Then here we've been establishing that this is under 3%, 10% under 3, which is 2.487. So we'll divide this figure into the 1,000 there. What becomes our R? What is 2.487 into 1,000? What becomes our R? 402, is it? Quickly, what are you getting? 1,000 divided by 2.487, what are you getting?
402.09.
402. It's a periodic payment. So to amortize a loan is to finish paying a loan, to set up a plan. All right, you start with balance at the beginning. Then we go to the periodic payment. We go to the interest rate. Then we go to the balance paid or loan repaid. Then finally, you go to the closing balance. So you need to master this. We have column 1, column 2, column 3, column 4, and column 5. So we started with 1,000 kwacha. The periodic payment, we've already established we are 402. It must be the same throughout. 402, 402, and 402. Okay. So interest rate was what percentage? 10%. So here we're just calculating column 1 times what? 10% times the rate. So 10% of this one is what? 100. Then column 4 is simply column 2 minus column 3. So what is 402 minus 100? 302. Then column 5, we're just subtracting column 1 minus column 4. So 1000 minus 302, what are you getting quickly?
698.
698. So this will be the opening balance here. C5 brought down 698. Then how do we get column 3? 10% of this one is what? 69.8. How do we get this column 4? Subtract these two. What do you get?
296.
96.2. Then how do we get this column here? Subtract this from the opening balance. What are you getting?
402.
402. So 402 will be our opening balance here. Then 10% of this one is 40 point what? 40 point.
40 point.
Then when you subtract these two, what are you getting? To get column 4 is column 2 minus column 3. What are you getting?
361.8.
361.8. Okay, so you subtract this minus that. What are you getting? It's almost 0. Okay, what are you getting? Okay, so meaning we would have amortized this loan. This is a repayment schedule. So this is what we call loan amortization. The figure here is usually very small. So we use the present value annuity factor. So we end here. Our next class will be POM. Please prepare. Have a good evening.
Thank you.